Just going to have a look here at a worked example of Skew Boreholes question, just to kind of walk through step by step, thinking in terms of key principles, what's actually involved in a common example of a Skew Boreholes question. So we can read our question there. On a contour map, A and B are 2 points whose altitudes are 90 meters and 100 meters respectively. On the map, A is located 65 meters south of B. A skew borehole at A is drilled in a southwesterly direction in plan and has an actual inclination of 60 degrees to the horizontal plane. It reveals the top and bottom surfaces of a stratum of ore at altitudes 60 meters and 30 meters respectively. Skew borehole at B is drilled in a southeasterly direction in plan and has an actual inclination of 40 degrees to the horizontal plane. It reveals the top and bottom surfaces of a stratum at altitudes of 80 meters and 10 meters respectively. Determine the dip, strike and thickness of the stratum. So straight away we see there how text heavy these questions actually are in comparison to other elements of DCG, that it would be much more focused on the numbers rather than the actual text, and there'd be a little bit less understanding involved in what's being asked when it comes to other questions. But the key thing here is to take the information that we really need and put that to good use, rather than getting bogged down with the stuff we don't need. So say on the contour map, A and B are 2 points. So there's our 2 points. Their altitudes are 90 meters, 100 meters respectively. That's a key element of information. So I'd write that down, or even just underline it. On the map, A is located 65 meters south of B. Another key. So we can go down through it all the way. 60 degrees to horizontal plane. That's a key piece of information. It reveals the top and bottom surfaces of the stratum, 60 and 30 meters respectively. Another key piece. So you get the idea there. 40 degrees again, 80 and 10, they're all our key pieces. Now going back to our terminology that we discussed in the intro, determine the dip, strike and thickness of the stratum. So we understand what's actually being asked. If we don't, then we'd need to go back and have a look at the terminology used, because we're going to get those terms in every single question, and frankly we won't be able to complete the question unless we have a good understanding. So we'll just rock on there. So that's set up. Just get up the picture here of the question again. So yeah, so there's our points A and points B. They're marked out at 100 meters and 90 meters in elevation, and then in plan they're marked out at 30 and 60 meters. So that's our question set up. Now straight away, in comparison to other questions on skew boreholes, we're not actually given the boreholes themselves. We have to draw them ourselves, but we are given the angles to the horizontal plane. So what we can do with that angle is we can just take any line, go 60 degrees to the horizontal plane. So that's gone on a nice bit there. So we'll go 60 degrees to the horizontal to A. We'll bring that line straight down. We'll come across from A in plan and we'll rotate. Once we've rotated to the south, what was the direction we've gone back? Southwesterly direction. So we've rotated to the southwesterly direction, which will be 45 degrees southwest. We stop there and then we come straight back up. That's given us our point on our horizontal. That means we can draw in borehole A in heavy. So that's borehole A done. So then the next step that we've taken here is to draw in the given points of the stratum. So at skew borehole A, they were 30 and 60 meters. So we've drawn in AH and AF, which is the head wall and the foot wall. So that's why we say AHAF. And we bring them, because it's at an angle, we can bring them straight down into plan and mark them in there nice and quickly. So that's that step done. So then on to B, again we're given our information. It's 40 degrees to the horizontal, so we draw our angle 40 up to B. We swing it down, we bring it down, come across horizontal from B, rotate it down until we get to our southeasterly direction, then bring that back up, and that will give us B in heavy. So that's our question set up. Again, we'll put in more information we're given, so we'll put in BH and we'll put in BF, which were given to us at 80 and 10 meters respectively. So they're set up, and we'll set them up in plan as well. Again, we can bring them straight down because they're all at an angle. Sometimes you'll be given ones that are vertical, you'll have to bring them down, rotate them around. We'll have a look at that later on in another example of question, but in this case we don't need to. So we can join AH and BH, and we can join AF and BF, both in elevation and in plan, because they are corresponding points on the head wall and the foot wall of the stratum of ore. And remember when we discussed in the intro about needing those lines parallel if we're to get the thickness, and as you can see from that question there, they are not parallel yet, so it means we have a lot of work to do yet. So they're in there. I don't know why my little annotations didn't come in there. So now what we want to do is we want to come across from AH, so we've gone a level line, and then we've gone parallel to AF and BF in elevation. So now we're trying to determine the strike here, which is what I should have said at the start. We're trying to determine the strike, so we've gone parallel, we've come straight across level line from AH, and then we've gone parallel to AF, BF in elevation until they hit, and they'll hit at what we've marked down here as point C. We bring point C down to plan. Now we do the same thing again. We come parallel from point BH, which is the same as we did in elevation, and we go parallel to AF, BF. Again, that will cross that line C somewhere, giving us our strike. Okay. Oh jeez, I thought that was only gone out of the picture there. Right, so that's our strike there. So we've gone through point C off up to the right hand side where we've loads of space. So yeah, that's the strike. That's one of the most important parts. Done. Then we're just going perpendicular line, and we bring up our points, taking our measurements from the elevation as we've always done. We're working back to. So we've AF, BF marked, AH, BH marked. We draw them in heavy, and there we go. They're parallel, so that's our thickness. So yeah, the thickness is marked in as T. Oh, there's my head wall and foot wall. That's great. So T is marked in. That's our thickness. Our dip then was one of the last parts of the questions that was asked, is just the angle between AF, BF and our horizontal line there, the perpendicular line to our strike. That can be taken as our horizontal. So that's the dip. That is the true dip, the true angle. Again, when we're talking about key principles, the true dip can be brought back to looking at auxiliary views, trying to find a plane, like a lamina as a line or an edge view. They're all fundamental things that we'd have done way back. The strike was the same. We said in our introduction, was like the laminas. You're coming across, you're coming down, you're finding the strike to find an auxiliary view. So they all kind of link in together. But that is, in essence, one of the example questions. Maybe a little bit harder with the setup, considering the information you were given, and you had to draw it in yourself. But I think that's just a good way of showing the way that these questions can be worded and then can be completed, and kind of putting a visual image to the words. So you have your dip, we've seen T as our thickness, and we have our strike there. So that's what we were asked for, and that's that done.